Yeah, good evening, students. I hope you had great holidays and now you are back to routine. Okay. Okay. I hope you remember that what was discussed in last class. We started discussion in last class with various parameters and hyperparameters related to this neural network model or any machine learning model, you may say, because these are the parameters and hyperparameters related to different machine learning models. And we also discussed the difference between hyperparameter and parameters. We saw that parameters are estimated using given data, while these hyperparameters are used to estimate the model's parameters. These hyperparameters, they are not estimated by the given data, but the parameters are, like if you remember, let me show you. If you remember, we discussed these parameters and hyperparameters, right? Weights, bias, number of hidden layer, number of neurons per hidden layer, batch size, learning rate, and number of epochs. Activation function, optimizers and loss function, yet they are left. Okay, today or probably next class, let's see that how much we can complete today. Okay, so accordingly, we may cover this activation function in this class or in next class. Fine. Okay, so at last discussed that what is hyperparameter tuning and why is it important and which are the different ways for hyperparameter tuning. And we saw two main approaches, manual hyperparameter tuning and automated hyperparameter tuning. And then we discussed the four different methods for automated hyperparameter tuning, and preferably this random search and grid search are used for automated hyperparameter tuning. Fine. Then we saw how do we choose a number of hidden layers. I hope you remember. If not, like let me tell you in one or two lines that how do we choose the number of hidden layers. Though this summary shows that how should we choose? Like if there are linearly separable data, then zero hidden layer is required. If nonlinear boundaries are there in given data, then 1 to 2 hidden layers can be set in our neural network. But in general, I may say that number of hidden layers is a hyperparameter that can significantly impact the model performance, and increasing the hidden layers can allow the model to learn more complex relationships in data. And it cannot increase the risk but still it can also increase when we increase the number of hidden layers. It also increases the risk of overfitting and it requires more computational resources. Okay, so overfitting we did not discuss in last class, so today I shall discuss overfitting also, that what is overfitting. Okay, but this, like if you increase the number of hidden layers to learn more complex relationships in data, it also increases the risk of overfitting that we discussed in last class. Then we also saw how to choose a number of neurons. And this is the summary in table, that how to choose number of neurons. If the problem is simple and the input output relationship is clear to you, then about two-thirds of the input size can be uh, the starting point for number of neurons. And but if the relationship between input and output is complex, then the number can vary from the input size to less than twice the input size as given in this table. So that is how we set the number of neurons in neural network. And then we also discuss how to choose batch size, learning rate, and epoch. And these are correlated hyperparameters. And we also saw that the normal batch size is 32, but you can also try with 32, 64, 128 to 56, and so on. And then based on the performance, you can choose 32 or some other value. So in neural network, like whenever we start, we always have beginning settings for this hyperparameters, but then through exhaustive experimentation, we set them. Like it is not, we have set initially 32, so it will not be 32. We have to check with 32 and some different numbers like 64, 128, and so on. And then based on performance, we set one value for batch size. Similarly, epoch also, similarly, learning rate also. So the settings which we make initially are not the final settings for this parameters. They are only initial settings, and then based on performance, based on experiment results, we optimize these parameters through experimentation. Okay, learning rate also, as we discussed, we usually start with 0.1 or 0.001, or we can use like any searching method of grid search, random search, to choose the appropriate learning rate initially, right? And number of epochs also we discussed, like depending on the problem and random initialization, the number of epochs you need for convergence of your model varies. So there is no like standard formula to decide the number of epochs also. In practice, we often set the number of epochs high and we use early stopping so that the neural network stops training when the improvement coming from the updated weights. So we discussed this much in last class. So we revised those concepts in this initial 5 minutes. Okay, now let's see the next topic. Okay. Okay, overfitting is lab, because we saw that when we increase the number of hidden layers, we also increase the number of neurons, and they may lead to overfitting. So let us see what is overfitting and how can we avoid this overfitting. Fine. Okay, now before we discuss overfitting, let us understand this 4 terms which are related to this overfitting. These terms are, like, first is signal. So what is signal? Signal refers to the true underlying pattern of the data, like hidden pattern of the data that helps machine learning model. Here I have used machine learning model word, not using neural network, because this is the concept related to any machine learning model, including this neural network. So this may happen, this overfitting may happen when we use any machine learning model, right? Because neural network is one of the ways to train your machine, to make machine learn from the given data. But there are other ways also using which machines can learn, other algorithms also using which machines can learn from the given data. So this is the concept related to any machine learning model, including neural network. Okay, so this signal refers to the true underlying pattern of the data that helps the machine learning model to learn from the data. So that is called signal. These are very simple terms. Noise, what is noise? It is unnecessary and irrelevant data that reduces the performance of model, right? Those who are familiar with data science, or they might be familiar with outliers also. So we can consider outlier as the noise. Noise is unnecessary and irrelevant data because it is unusable data. It reduces the performance of the model. Okay, so noise, when we prepare our data to fit to machine learning model, we remove this noise, and there are different noise filtering techniques available depending on the type of the data, because data may be text data, data may be voice data, data may be image data. So depending on the type of data, we have different noise removal techniques, and this unwanted data is removed using this noise removal technique because it is unwanted data and that may hamper the performance of our model. So that is called noise. Okay, now what is bias? Okay, this bias and variance are very important terms related to model. Bias, like assumptions made by a model to make a function easier to learn. Or in simple terms, let me tell you, it is actually the error rate of the training data. When the error rate has also, as defined here, like what is it? It is the difference between the predicted values and the actual values. It is the difference between the predicted value, that is values predicted by your machine learning model, and the actual value associated with that input data. Okay, so we find the difference between the value predicted by the machine learning model and the value given with that input data, because let's assume it is in label data. So with in label data associated with each input, the output is also given. So we know that what output is expected for this input. So, and there will also be one value which will be predicted by machine uh, for that input value. So we find the difference between predicted value and actual value, and the error this difference, which is called error, it is known as bias. Okay, now what is this bias? Bias, like if it, which is error rate. Okay, so when the error rate has a high value, we call it high bias. And when the error rate has low value, we call it low bias. I hope this is very clear. Low error rate, low bias, high error rate, high bias. Okay, so this is called bias. Now, what is variance? It is the difference between the error rate of training data and testing data. Difference between the error rate of training data and testing data. So as given here, if machine learning model performs well with the training data set, but does not perform well with the test data, we can say that variance occurs. Machine learning model performs well with the training data set. I hope you remember that given data set is divided into two parts, training data set and testing data set. First, we train machine with the training data, and then the performance of that trained model, it is evaluated with testing data. Okay, so if machine learning model performs well with the training data, but it does not perform well with the test data, then we may say that the variance occurs. The difference between, or in other words, difference between the error rate of training data and testing data is called variance. If the difference is high, if this difference is high, it is called high variance. And when the difference in errors is low, it is called low variance. Which difference? Difference between the error rate of training data and testing data. And usually we want to make a low variance for to generalize our model. Definitely, the difference between error rate of training data and testing data should be low. Then we can say that the model generalized like good. Okay, so this variance should be low. So that we want with our model. So these are the four terms related to like when we train our model. These are the four terms related to this underfitting and overfitting. Okay, now let's see what is underfitting and overfitting. Okay, so this there are two terms related to this underfitting and overfitting when we talk about the machine learning model. Okay, this underfitting and overfitting, they talk about how well machine learning model performs and how well is its accuracy. Accuracy, we can measure considering the prediction errors made by the machine learning model. Let us consider that we are designing a machine learning model and the model is said to be a good machine learning model if it generalizes any new input data from the problem domain. Of course, right? We have trained it. If I train you with a particular handwriting for alphabets A to Z, then I have trained you with that particular set of handwriting. So once I train you with that set, you will be able to identify which is alphabet A, which is alphabet B. But after giving you training of this different set of alphabets, if tomorrow I give you a new, if I give you English writing in new handwriting, which is not there in your training set, then you should be able to identify A to Z. If you are not able to identify A to Z from that new writing, new handwriting, then your learning is poor because you are able to identify A to Z only from that set of handwriting which I provided you during learning. But you are not able to identify because it is like very messy. Let's assume that the handwriting is not good and you are not able to identify which is A, which is B, which is C, or some of the alphabets, not all alphabets, but some of the alphabets you are not able to identify. It means that your learning is not good. Okay. Or you are not able to identify the alphabets when it is written in complex style, when these alphabets are written in complex style. So this way, when we say that machine learning model generalizes when it is able to identify, when it is able to predict label for new input data, which is unseen to it. Okay, so this is like called that when it is able to do that, we say that it's a good machine learning model. And this helps us to make predictions about future data that the data model has, future data, that means the data model has never seen. Now, suppose we want to check how well our machine learning model learns and generalizes to the new data. For that, we have overfitting and underfitting, which are majorly responsible for the poor performance of the machine learning models, or you can say machine learning algorithms. Okay. So let us first see what is underfitting. Fine. Let us first see what is underfitting. Okay. Okay. Some messages there in chat box. Let me check it. Okay, tuning. I think this message was written before I discussed. I don't know whether after my discussion or before my discussion, because we discussed hyperparameter tuning. Dhruv has written a question in chat box that can you please give quick overview of tuning? I gave you quick overview of tuning initially. Okay. Yeah. I hope it is clear now because we discussed in last class. Moreover, in first 5 minutes, we revised those concepts. What is hyperparameter tuning? It is optimizing the hyperparameters. That is called hyperparameter tuning. Deciding the optimal values for different parameters. Okay, fine. So what is underfitting? Let us focus now on underfitting. Uh, any machine learning algorithm is said to have underfitting when it cannot capture the underlying patterns, underlying trends of the data. Any machine learning algorithm, any machine learning model, including this. Just a second, students, give me 1 minute. Yeah, I am very sorry. Yeah, I'm back. Yeah, so we were discussing underfitting. Machine learning algorithm or any machine learning model, it is said to have underfitting when it is not able to capture the underlying patterns or underlying trends of the data. So that is, it only performs well on training data, but it performs poorly on testing data. It performs well on training data, but it performs poorly on testing data. So that is called underfitting. It is just like trying to fit undersized, undersized clothes. So underfitting destroys the accuracy of machine learning model, and its occurrence simply means that our model or algorithm does not feed the data well enough. So that is called underfitting. It usually happens when we have less data to build an accurate model, and also when we try to build a linear model with fewer nonlinear data. So in several real life sectors, today we have less digital data, and uh, if we try to train our model with less amount of data, underfitting may occur because the training is not good, right? So it is able, when training is not good, it performs well only on training data, but it does not perform well on testing data, because new data may new data with new patterns, data with new trends may be fed to that model in future, and it has not got training for those patterns or those trends, so it may not make accurate predictions in that case. So in that case, underfitting occurs. I hope you understand. We are training model with a less amount of data, so it will be able to learn features from that data, but in future it may be fed, that trained model may be fed with data with new patterns, with new trends, but it has not learned those patterns, it has not learned those trends, so it may not be able to make accurate predictions for that data, and we can say that model like underfitting has occurred. In such cases, the rules of machine learning model are too easy and flexible to be applied to such minimal data, and therefore model will probably make a lot of wrong predictions in case of underfitting. So underfitting can be avoided by using more data and also reducing the features by feature selections. Okay. So in summary, I can tell you that underfitting refers to a model that can neither performs well on the training data nor generalize to new data. And here are the reasons. I'll show you the reasons for underfitting. Here are the reasons for underfitting. Okay. So here you can see that the reasons are high bias and low variance. We have discussed what is bias and what is variance. Variance is difference between error of training data and error of testing data. And bias also we have seen. So when there is high bias and low variance, underfitting occurs. The second reason, the size of the training data set used is not enough. Then underfitting may occur. The third probable reason is model is too simple. The model which we have created, the architecture of model or model which we are using is too simple. It's not able to learn the patterns. It's not able to learn the underlying trends in data. Then underfitting may occur because training, no good, it has not learned good. And if it has not learned good, it may make wrong predictions. So that is also one of the reasons. The next reason, the next probable reason is training data is not cleaned and also contains noise in it. If training data is not clean, it will learn wrong things because it's not clean. Garbage is also there. And this models, they work on garbage in, garbage out philosophy. So if you are inputting the wrong data or unclean data, then the training will not be like accordingly it will get trained, and the predictions or classifications may be wrong. So when your data is not clean, or you can say when it contains noise, underfitting may occur. And that's why always we perform data pre-processing before we feed this data to machine learning model for training. So that is called data cleansing, or you can say pre-processing the data, preparation of data before it is fed to machine learning model. Fine. So, and here now, okay, these are the reasons, like there one or two, there may be one or more than one reasons are, uh, 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 like one or more reasons are responsible for creating this underfitting. And these are the techniques which can be used to reduce underfitting. We can increase the complexity of model because one of the reasons is model is too simple. So we don't know, when we don't know the exact reason and when underfitting occurs, we have to try with all, like we can increase the complexity of model, we can increase the number of features and perform the feature engineering. Feature engineering is for feature selection. So that is like, again, a separate topic which can be, you can go through it. It is a part of machine learning and you can go through it, that what is feature engineering. So we select features, we drop some of the features, and so we can increase the number of features and perform feature engineering. We can remove noise because as we have seen in the last reason, that training data may be noisy. So we can remove noise from the training data. We can also increase the number of epochs because training may be less. And if there is less training, then underfitting may occur. So for that, we can increase the number of epochs, or we can increase the duration of training to get better results, because we need to improve the model's training. We need to increase its training. So these are the different ways to reduce the underfitting. Okay. Like again, this is those who have learned, I am sure those who have learned machine learning, they are familiar with these concepts because this is mainly fall under machine learning subject. But it is related to neural network also, because neural network is one of the model used to train machines. So I'm discussing it again. Okay, now let's see overfitting. What is overfitting? Underfitting we have seen. Overfitting is like we can say that model is said to be overfitted when the model does not make accurate prediction on testing data. Model is said to be overfitted when model does not make accurate predictions for testing data. When model gets trained with so much data, now this is C, underfitting occurs when model is trained with less amount of data. Overfitting occurs when model is trained with so much data. It starts learning from the noise and inaccurate data entries in our data set. And when testing with test data results in high variance, we can say that overfitting has occurred. Then model does not categorize the data correctly when overfitting occurs because of too many details and noise in the data. The causes of the overfitting are non-parametric and non-linear methods, because these types of machine learning methods have more freedom in building the model based on the data set, and therefore they can really build unrealistic models. So a solution to avoid this overfitting is using a linear algorithm if we have linear data, or using the parameters like the maximal depth if we are using decision trees. Now, these are machine learning models, right? In summary, I can say that overfitting is a problem where evaluation of machine learning model on training data is different from unseen data. Evaluation of machine learning model, including this neural network model, on training data is different from unseen data. So we can say that overfitting has occurred. And here are the reasons, like probable reasons for overfitting: high variance, low bias. Now you can see that it is different from underfitting. In underfitting, you can see that high bias and low variance, while for overfitting, variance would be high and bias would be low. Okay, so high variance and low bias. Model is too complex. In that case, in case of underfitting, when model is too simple, underfitting may occur. If model is too complex, overfitting may occur. Size of the training data, like here you know that if the size of the training data set is not sufficient, if it is small, underfitting may occur. Overfitting, if the size of the training data is too big, then overfitting may occur. Okay, so these are the probable reasons for overfitting, and here are the techniques to reduce, like they both are contradictory concepts, underfitting and overfitting. And here are the techniques using which we can overcome this overfitting. We can increase the training data, like the size of the training data. I said that increase the training data, but the good data, we need to remove the noise. Okay, we need to remove the noisy data, we need to remove the outliers, and we can increase the quality data in our training data set. The second technique is reduce model complexity, because we have seen that one of the possibility why overfitting has occurred is model is too complex in its architecture. So we can reduce the model's complexity. The third, like this is very popular technique we use to avoid this overfitting: early stopping. Early stopping during the training phase, right? So we can keep watch on over. We can keep watch on loss over the training period. As soon as loss begins to increase, we can stop training. So that is called early stopping. Okay, and regularization technique is also very popular, which is used to avoid this overfitting. And we have two popular regularization techniques to overcome this overfitting problem, and these are ridge regularization and lasso regularization. This also, those who have learned machine learning, they must be familiar with this regularization techniques, ridge and lasso regularization techniques. And we can also use dropout for neural networks to tackle overfitting. This is specially for neural networks. Dropout technique is specially for neural networks. Okay, so I'll discuss it in detail, because if you have not learned neural networks thoroughly in machine learning subject, you might have not learned dropout. So I'll briefly tell you about what is dropout for neural network models, because as I told you, there are several machine learning algorithms. There are several machine learning techniques which we use to give training to machines. I tell you again that I use these words interchangeably: techniques, algorithms, models, methods, because machine learning algorithms, they are also called machine learning techniques, they are also called machine learning models, they are also called machine learning methods. So I mean the same when I use these different words, right? Techniques, algorithms, models, methods, approaches. So I mean the same because in literature you will find use of different words for this machine learning algorithms. Okay. So among the several machine learning algorithms, neural networks is one of them because you can train machines using neural networks also. So dropout can be used for neural networks to tackle the overfitting. So that is called, okay, that is one of the ways to overcome the overfitting. Now before I discuss dropout, I would like to discuss one more concept related to this underfitting and overfitting. There is one more term known as good fit. Underfitting, overfitting, and good fit. So what is good fit for machine learning model? I forgot to okay, fine, I can orally discuss, though I have not included any slide related to this good fit, right? Because we have seen that underfitting and overfitting. When underfitting occurs, model does not perform good. There may be wrong predictions. When overfitting occurs, model does not perform good. There may be wrong predictions. Okay, so both this underfitting and overfitted models are not good models. So we need good fit in machine learning model. We need good fit. So what is that good fit? Ideally, the case when the model makes the predictions with zero error. Of course, right? Because we have seen that's why I introduced that bias and variance. Okay, zero error. So variance should be what is variance? Difference between error of training and error of testing. If the difference is zero, right? When the model makes the predictions with zero error, it is said to have a good fit on the data. This situation is achievable at a spot between the overfitting and underfitting. Good fit is between overfitting and underfitting. To understand this, we should have look at the performance of our model with the passage of time when we are training it. Over the time, we should monitor its performance. While it is learning from the testing data, we should monitor its performance. Over the time, if our model will keep on learning and error for the model on the training and testing data will keep on decreasing, then we may say that model is performing good. If it will learn for too long, model will become more prone to overfitting due to presence of noise and less useful details in our data. If we train it for too long, right? If we train it for too long, right, you do know, किसी भी चीज में ज्यादा अगर ट्रेनिंग दी जाए, ज्यादा इंफॉर्मेशन प्रोवाइड की जाए, right, then you may learn useful information, you will get useful information also and you will get unuseful information also. Okay, so if model will be trained for too long, the model will become more prone to overfitting due to presence of noise and also due to presence of less useful data, details in data. Thus, performance of model will decrease. Okay, and to get a good fit, we will stop at a point just before where the error starts increasing. Okay, when the error starts increasing, so we should stop it. At this point, the model is said to have good skills in training data sets as well as our unseen testing data set. So this is called good fit. So when error starts increasing, we should stop training model, because when error increases, it means it has start learning noise, it has start learning, it has start getting wrong details from the data. So that's why error is increasing, right? So we can use the that is called good fit. We should stop training when error starts increasing. So that is about overfitting and underfitting, these two concepts related to machine learning model and also related to neural network model. Okay. I told you that dropout concept is used to overcome overfitting specifically in neural network. So let us discuss what is dropout. Okay. Fine. So dropout, here you can see the problem which occurs when we train our machine learning model. So what's this problem? Uh, when a fully connected layer has a large number of, which layer? I'm talking about the hidden layers, okay? Fully connected hidden layers. Fully connected hidden layers in our neural network model. When a fully connected layer has a large number of neurons, co-adaptation is more likely to happen. Now, what is co-adaptation? Co-adaptation is more like there are hidden layers, and in hidden layer, there are more number of neurons. Okay. When there are more number of neurons, please imagine there are hidden layers and there are more number of neurons in hidden layer. Now, when there are more number of neurons in hidden layer, co-adaptation is likely to happen. Now, what is co-adaptation? Co-adaptation refers to when multiple neurons in a layer extract the same or very similar information from the input data. Co-adaptation refers to when multiple neurons in hidden layer, they learn the similar features, same or similar features from the input data, similar information, or you may say similar information or similar features. Then we can, from the data, then we may say that co-adaptation has occurred. And this co-adaptation can happen when the connection weights. Please remember, please recall the architecture of neural network. We have input layer, we have hidden layers, and finally we have output layer. Okay. So hidden layer, there may be 0 or 1 or 2 or more hidden layers are there. Fine. Now, there are on connections, there is one value which is called weight value. So this co-adaptation can happen when the connection weights, the weight values for two different neurons are nearly identical. When the connection weights for two different neurons are nearly identical, then co-adaptation occurs because weight values are same. Okay. Now, when co-adaptation occurs, it leads to two different problems, two different issues as mentioned here when co-adaptation occurs. I hope it is clear what is co-adaptation. Okay. Co-adaptation is when multiple neurons in layer extract the same or similar information from the input data. Okay, now this co-adaptation, when this co-adaptation occurs, it leads to two different issues. Wastage of machine's resources when computing the same output, because machine, through different neurons, machine is learning the same information. Machine is learning the same hidden patterns from different neurons. So it wastes the machine's resources when computing the same output. And the second problem is if many neurons are extracting the same features, same information, same hidden patterns, same trends. I'm using these words also interchangeably: features, trends, patterns, information, right? So when many neurons are extracting the same features, it adds more significance to those features for our model. आप एक ही चीज बार बार लर्न करते हो तो आपको ज्यादा याद रह जाती है, राइट? आपको लगता है यही सही है. Okay, so this leads to overfitting because it is learning the same features again and again. So in that case, it leads to overfitting. So these issues may occur in our model. Okay, when co-adaptation occurs. So what's the solution for this problem? So we can overcome this problem as the title suggests, dropout in neural network. So as the title suggests, we use dropout while training the neural network to minimize this co-adaptation. Dropout is used to minimize co-adaptation in neural network. I hope it's clear. So in dropout, what we do, we randomly shut down some fraction of layers neurons at each training step. Randomly, we drop some of the neurons from the hidden layer at each training step by zeroing out the neuron values, right? Matlab, we set the we set weight value to 0 for those neurons. So they are called dropped neurons. So we shut down those neurons in our hidden layer. So how do we shut down them? How do we remove them? Remove means we are not actually removing, but we are setting their weights to 0. And the fraction of neurons to be zeroed out is known as the dropout rate. That fraction of neurons, that how many neurons we are, for how many neurons we are setting weight value to 0. So that fraction is known as dropout rate. So, and the remaining neurons, they have their weight values, and the overall, like we may have fraction. For example, there may be 6 neurons in our hidden layer. And suppose, for example, in first step, weight value for 2 neurons to 0, and for the remaining neurons, the weight value is set to some number. Okay, so that is possible. Like we may also do in next time, we may also set value different neurons to 0, because we have 6, right? So 1, 2, 3, 4, 5, 6 neurons are there in hidden layer. So first time we may set weight value of neurons 1 and 2 to 0, and we may check the performance. Next time we may set weight value of neurons 3 and 4 to 0, and so on. The two, like, okay, so, but we need to make sure that in multiple training steps, we set the weight value for different neurons to 0, but the dropout rate, like if out of 6, we are setting weight value of 2 neurons to 0, we can say that dropout rate is 1/3. Because I hope this is clear. 1/3, okay? 2 out of 6. So 2 divided by 6. So 2 divided by 6 means 1 divided by 3, 1/3. Okay, so it would be 1/3, the drop rate. If it is 3 out of 6, what will be the dropout rate? I hope you will be able to compute. If I am setting weight value for 3 neurons to 0, you can write your answer in chat box. If I am setting weight value for 3 neurons to 0 out of 6 neurons in that hidden layer, then what will be the dropout rate? You can write in chat box. Yes, half. Absolutely right. No, 1 is not correct, because it is 3 divided by 6. Out of 6, 3, weight value of 3 is set to 0. Yeah. Yes, so majority of you have understood this concept correctly. So dropout rate in that case would be 1/2, because remaining neurons. Okay, so every time like that, we are choosing a random sample of neurons rather than training the whole network at once, right? So this ensures the co-adaptation is solved, and model learn the hidden features better. Okay, so I would like to tell you why this dropout works for neural network. Why this dropout works for neural network? By using dropout in every iteration. I told you every iteration means every epoch. We provide training via multiple iterations. Okay, so using dropout in every iteration, you will work on a smaller neural network than the previous one, and therefore it reaches regularization. And second thing, dropout helps in shrinking the squared norm of the weights, and this tends to a reduction in overfitting. So these are the main two reasons that why dropout works for neural network. Okay. Okay. So that this is about the common terms related to hyperparameter tuning. Still, we have not discussed activation functions, learning rate, sorry, function, loss function, and optimizers. Okay, someone was asking me initially that can you please repeat the hyperparameter tuning? So if you have missed previous discussion, the discussion in last class regarding hyperparameter tuning, please get I'm discussing that hyperparameter concept, hyperparameter tuning concept now with example. Okay, before I discuss that optimizer, loss function, and activation function. So here I have included example that how hyperparameter tuning works. So this will help you to recall all previously discussed concepts. Okay. Okay. Let us say we are building a neural network to classify images of animals. Some neural network hyperparameters we want to tune. So let us assume they are learning rate, the number of layers in neural network, and batch size. Let us assume that we want to optimize these three parameters for the neural network which we have created to classify images of animals. We want to tune these three parameters: learning rate, number of layers in network, and batch size. Fine. Okay. Now here, as we discussed, either we can use manual way to set this hyperparameters, or we can use automated way. In automated way, there are four different methods. Like I told you that random search and grid search are very popular. Let us assume we use grid search. So we can use grid search to find the optimal values for these parameters. To do this, what we do, we first define a range of values. Please remember, please listen carefully. How do we find the optimized value for these parameters? To find the optimal value for these parameters, we first define a range of values for each parameter we want to tune. We want to tune means we want to optimize. Okay. So we first define range. So for example, we might define this range for these three parameters. For learning rate, as you can see, the first step, first define a range of value for each hyperparameter we want to tune. So let us assume for learning rate, we are setting this range. We are defining this range 0.001 to 0.1, sorry. Number of layers, number of hidden layers. Okay, this is number of hidden layers. 1 to 5, we may set 1, we may set 2, then 3, then 4 and 5. Setting different values, we will experiment. Okay. Batch size 32 to 128. But I told you 32 to 128 doesn't mean that we have to start, we have to set 32, 33, 34, 35. No, it's always in uh, uh, power to 2. Okay. So 32 to 128 means 32, 64 and 128. So that is the first step. Okay. Now second step. Okay. What is the second step? Once we do that, next we create a grid of all possible combinations. Okay. Please listen carefully. Now we create a grid of all possible combinations of these values. For example, if we have these values, because learning rate, we set the range 0.001 to 0.1. So the set, if we create for different values of learning rate, it is 0.01, 0.01 and 0.1. Three values are possible for learning rate. We choose odd number of layers, not even number of layers. So 1, 3 and 5. So in set, we have three possible values, 1, 3 or 5. In set of beds, possible bed sizes, we have three values, 32, 64 and 128. Okay. So how many combinations are possible with these three parameters? The grid will have total. Can you tell me how many combinations are possible? You can write your answer in chat box. How many combinations are possible with these three different values for this three parameters? Write in chat box, different combinations. Three values are possible for learning rate, three possible values for number of layers, and three possible values for batch size. So total combinations, this is maths now. Now I'm not assessing your machine learning or deep learning knowledge. This is maths, right? Three parameters are there. For each of these three parameters, three values are there. So how many combinations are possible? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119 Uh, okay, I'm getting one answer, 27. Then 3 factorial, then 729, 27. 27 is right answer. 27 is right answer. 3 into 3 into 3. 3 into 3 into 3. How? I'll tell you. I tell you now, as I'm not teaching offline, I'll not be able to show you like on board. But please be with me when I'm telling you. Imagine, okay, the first possible combination 0.01, number of 1, batch size 32, one combination. Second combination, learning rate 0.001 only, number of layers 1 only, but batch size I am choosing 64. That is my second combination. The third, learning rate 0.001 only, number of layers 1 only, but batch size 128. So 3 combinations. Okay, next 3 combinations. Let learning rate be 0.001. Let number of layers 3 now, and different batch sizes. So other three uh, combinations. Next 3 combinations, learning rate 0.001 only, but layers 5 and all 3 batch sizes. So more 3 combinations. So total 9 combinations are there. Okay. For one learning rate, 9 combinations. For remaining 2 learning rate, other 9 combinations. So total 27, 3 into 3 into 3, total 27. You can later you can try in notebook. Total 27 combinations would be there. Okay. So how do we tune this parameter? See, so first is define a range for each of the parameter you want to tune. Next, create a grid of all possible combinations of these values. Okay, that is second step. And the third step is then the grid will have all the possible combinations. Now train neural network for each combination, evaluate model, like train means evaluate neural network for each combination and record the results. That's why I told you many times that to decide upon the optimal value of these parameters, you need exhaustive experimentation. In machine learning, nothing is decided in one go. If you want to tune these parameters, you have to experiment your model, your machine learning algorithm multiple times, right? So now train your neural network with different combination and record the results. For example, we might accuracy of each model on a Bayesian set. And finally, we choose the combination of that we can choose the combination that produces the best results. Finally, we choose the combination that produces the best results. So for example, combining a learning rate of 0.001, 3 layers and batch size of 64, for example, produce the highest accuracy. Then we can set these 3 parameters with 0.001 learning rate, 3 hidden layers and batch size 64, because this combination produce the highest accuracy. So this combination would be the optimal values for these 3 hyperparameters, and we would use these values to train the final model. I hope this is clear that how do we train, how do we optimize, how do we tune our hyperparameters. So in example, we have parameters. If you like, for example, you want to set values for example, say almost all or 5 hyperparameters, then you have to first define range for all those 5 parameters, make different combinations, try with each combination, record results, and choose combination which gives you best accuracy, which gives you higher accuracy. Okay, so this is called hyperparameter tuning. Okay, now we have I have some other engagements. So today also I'll not take, I would not like to go beyond 6 or 6:10. So now let me take your questions. Since last class, I wanted to discuss this. I'm not getting time, but probably next time. Okay. Oh, where is it? I included that slide is not there. I included it. I wanted to discuss I wanted to discuss this because the slide I missed when I discussed supervised learning, unsupervised learning, and reinforcement learning. The clear differences between these three learning techniques. Okay, but sometime like probably next class I'll discuss. Last time also I remember to discuss it, but I didn't get time today also, because now I would like to take your questions. So probably next time we will discuss the differences between these three techniques. And then we also have to see different optimizers, different activation functions, and different loss functions. I'm going slow for the first unit because I know that some of you have not learned machine learning, and these concepts are not clear to you, and we cannot move forward, or we cannot move further until these concepts are not clear to you. So once I introduce, you can explore them in deep. You can search in Google, and you can get in-depth information from Google or some other resources. So, but I thought that I should introduce these terms briefly before I move to next topics. Fine. So, questions from